Hello, students. All right, today we are I'll be teaching you on scale drawing. All right, so what is scale drawing all about? Uh, okay, scale drawing is just is all about bringing reality into a model or into uh, drawing. Okay, for example, if you are asked to draw a skyscraper or 20-story building, if you are asked to draw a skyscraper or 20-story building, all right. If you are asked to draw it in a plain sheet, I'm sure the height of the 20-story building could be up to, depending on, it could be it can be up to 200 meters. Yes, the height of a story building can be 200 meters high, can be 200 meters high. All right, and so it can be 200 meters high. So you can imagine you are asked to draw, and let's say that's the height. So let's say the base is around 100, let's say 50 meters. 50 meters. So you are asked to draw the height of this story building in your small A4 paper or sheet or your notebook. So, and you're going to have to draw it with precision, with accuracy. So what you are going to do for you to have this accurate 20-story building in your book is by reducing the scale. So you reduce the scale of the building. Of course, even your one A4 paper cannot accommodate up to 30 centimeters. It can't. It cannot even accommodate 20 centimeters. That's your A4 paper or your notebook. The maximum you can have is let's say 10 meters, 10 centimeters. You can have like 12, depending on how the book is. On your higher education, you can have like 15 or probably 20 centimeters. But you can't have more than the maximum you can have is probably 30 centimeters, depending on how big your book is. And you have to draw a 200-meter story building in that book. So what you are going to do to get the accuracy of the building is by reducing the scale. So that process is called scale drawing. Architects also they make use of scale drawing. If they want to draw a building or a skyscraper, they are going to have to draw it in like a form of paper. You know, there's a name they call it. So what they have done is that what they want to build to that mighty building is what they have drawn inside the paper. So what they will do is they have reduced the scale on the paper. So by the time they want to build it, they now maximize it. All right. So that is what scale drawing is all about. Okay. So the one that you draw on paper is the one we call the one we call the model. The one we call the model. That's the one you model, or the drawing, or the scale drawing. Why the main one is called the actual. That's the real drawing. All right. So this is an example. This is an example. All right. So the scale of a drawing is one. All right. So and the scale of a drawing usually have its ratio. It has its ratio. All right. So for the building I just did for you, that this has 200 meters and this has 50 meters. So I can call this, if I say 200 meters over 50, so this is, so the building I can say is, so this is the main building, but I have not reduced it. If I reduce it, that's when I can give you the scale. If I reduce it, that's when I can give you the scale. For example, this building I just used as an example. If I want to draw it in a paper, I can say this 200 meter, let my 200 meter, let it be just 10 centimeters. So if I say 200 is 10 centimeters, it means that when I want to draw 20, when I want to replace this 20 meters in my book, I will replace it with 10 centimeters. So then 1 centimeter. So if 10 centimeter gives me 200, then 1 centimeter will give me 20 meters. Right? Then 50 meters will give me what? So that's this will give me let's see 2 point that's divided by 4. That's 2.5 centimeters. So it means that when I want to draw this in my book, this story building, so I'm going to draw, I just draw 10, this is my 10 centimeters. So, and I will draw 2.5. This is my 2.5. So, sorry because it's small because I'm using so by my measurement by this is 2.5 centimeters. This is 10 centimeters. So what I've done now is that I've used ratio 1:20. So 1:20, that's what I've done. So this scale is okay, so my scale now is 200. I want to take this at 200 meters. Okay, let me say 10 centimeters over 200 meters. That's 10 centimeters over if I convert meters to centimeters, I have 200 times 100,000. Sorry, that's times 100. That's 100. That's 100. Sorry, 100 centimeter make 1 meter. So I have so the ratio of this building is ratio 1:2000. So the ratio of this building that I drew with this building is 1:2000. Alright, so let's continue. So I'll still continue with this explanation. So now, the scale of a diagram is 1 centimeter ratio 10 centimeter. They have given us the scale. He said the length AB on the actual diagram is 0.3. So the actual diagram is 0.3. So what is the length on the scale drawing? So they said the ratio is 1 centimeter ratio 10 centimeter. It means that the big one is the 10 centimeter, the actual. So the scale one is what they represent to the 1 centimeter. Right? So just come here. So they ask you to find the length. So what you need to do is you can represent as 1 centimeter ratio 10 centimeter, meaning that 10 centimeter equals to 1 centimeter, right? So the actual, remember, this 10 centimeter is representing the actual, and this 1 centimeter is representing the drawing, the scale drawing. So, and you are asked to find, so what is the length of the scale drawing? They want you to find this side. This is the scale drawing, and they want you to find the scale drawing. They've given you the actual. This 10 centimeter represents the actual, and 0.3 meters also represent the actual. So you are looking for x. Then the x will be equal to, by cross multiplying. Remember this method is just like 2 books gives 10. We gave 10 books to 2 men. So how many? 1 book. You give it to how many? You understand this kind of method. So that's what we are trying to do here. So if 10 centimeter equals 1 centimeter, then 0.3 meter equals to x, it equals x, and the x will be 0.3 meters times 1 centimeter over 10 centimeter. Centimeter cancels centimeter, so this will be 0.3 over 10 meters. So times 10 times 10. We want to convert this. So that's 3 over 100. That's 0.03 meters. That's our answer. So the answer to this, so the length of the drawing is 0.03 meters or 30 centimeters. You convert it to centimeters or 20 centimeters. Question 2. The plan of a building of a school playing field is drawn to a scale of solution 1:2000. So meaning that the real drawing is represented with 2000. So which is the actual drawing. So the scale drawing is represented to 1. So you have to find, say the length of this field on the scale drawing is 6. So meaning that my 6 is the scale. I just say 1 equals to 2000. So the scale drawing, I put it under the scale, which is 6 centimeter equals to x. Then my x will be equals to multiply 6 centimeter times 2000, 6 centimeter times 2000 over this 1. The same thing here. 0.3 meter times 1 centimeter over 10 centimeter. So if you multiply that together, you have that's 12,000 centimeters. So meaning that the scale drawing is 6,000, while the actual length of the field is 12,000 centimeters in centimeters. So A, that's 12,000 in centimeters. Then B in meters, that's what? 120 meters. Remember, 100 centimeters make 1 meters. So if 100 centimeters make 1 meters, then 120 meters make 12,000 centimeters. All right, thank you.